Now what do we have here? A lone oxygen atom. That's okay, because we have one over here. We can stick in there in its place. Now we got an OH over here. Just plop it over there and get another OH from here and take it over there. Now what we got left? We need one more H here. And now we've got this weird thing, this CH2OH. Now you might be wondering why it is that we didn't combine the H's and turn CH2OH into CH3O. And that's because if you take a look over here at the CH2OH, you'll see that the last H isn't connected to the C. So C is the carbon, H2 is the hydrogens connected to the carbon, O is the oxygen connected to the carbon, and H is the one hydrogen connected to the oxygen. I know we should have had the oxygen connected to the C as well, but we just don't do it for some reason. I'm not sure how exactly they defined it all and how they got it all to work, but that's just how they made it. Continuing. So, to make this weird molecule, we're going to get one last carbon. We're going to take that, move it over here, like so. Then, attached to that carbon, we're going to have two hydrogens, like so. There's one, and just like so, there's two. And then, attached to the carbon, we'll also have another oxygen, and attached to that oxygen we have one last hydrogen. Cool. So now what happens over here with these remaining oxygens? Well, quite simply, they all bond like so to become 6 oxygen molecules. As you can see, there's 6 over here. 12 atoms of oxygen in total, but it's only 6 molecules, because every 2 oxygen atoms bonds to become a molecule. And so, this is it, the miracle of photosynthesis. You may not see it right now, but this is quite important. And here's why. As you can see here, photosynthesis produces 2 things using the energy of sunlight. Now you may be wondering why you even need the energy of sunlight to begin with. Well, this thing isn't going to happen on its own. Molecules like to stay at the lowest possible energy state, and if they can go to a lower one, then they'll do it with ease. However, as you can see, somehow we've made it do this. It's got from these low energy states to something as complicated as this. And that's because we've given the molecules energy, and they're gonna do something with that energy, and they use that energy to go into a state like this. And then when it tries to fall back, it realizes that it can't, and so the energy is locked in a form like this. The only way to get the energy out is to add a little more energy in. Just like you gotta go up a mountain to fall off a cliff. You gotta add a little energy in before it all breaks down to bits, and all the energy will be released in a process called aerobic respiration. It's something that we humans do every day, but I'll leave that for another Teaching Tuesday. Thursday. Yeah, that's what I meant to say. Not save, James. Another thing this thing produces is oxygen, and that's also pretty important. Let me show you why. The sun makes energy, and energy goes to plants. The plants then get eaten by a hungry animal. In turn, the animal is eaten by carnivores like us, and that's where the energy goes. Technically, we're omnivores. So we can thank the plants for making the sun's energy into a usable form. Because it's a really hard job to turn the sun into sugar. And that's something only plants do. If it weren't for the plants and photosynthesis, then we wouldn't have energy. And without energy, we can't do anything. Not even grow, we wouldn't be here. Another important thing the plants do with photosynthesis, as mentioned earlier, is that they produce oxygen. And they produce this oxygen by taking in CO2, which, as you may or may not know, is exhaled by us. So the plants give us O2, and we take it, turn it into CO2. The plants take the CO2 and turn it back into O2. The cycle goes on, and so we're helping each other breathe. So without photosynthesis, we wouldn't be able to breathe. The CO2 and the O2 cycle is very important. It allows the plants to keep making more sugar with the energy from the sun. And the O2 is equally as important, because we need it to turn the energy back. We need it to turn the energy back. To turn that glucose back. And get that energy back. So, in conclusion, photosynthesis is what you see in front of you on this screen right here, right now. Photosynthesis gives us energy and oxygen to breathe, and without it, what does this even mean? So, another thing to note, every cycle, 9/10 of energy is lost. Only 1/10 makes it onto the next animal. So by the time it gets to the first herbivore... Sorry, messed up. So by the time it gets to the first animal, there'll only be 1/10 energy available. And at that first animal was just a herbivore, and then it was then eaten by a carnivore. The carnivore only gets 100%. I mean 100th of that original energy source. And so, as you can see, if the entirety of humanity became vegetarian and only ate products straight from plants, we'd save 10 times energy. If we let an animal eat a plant, and then an animal eat that animal, and then eat that animal, we'll only be getting a measly 1,000th of the energy, and all the other energy will be wasted. If the entire of humanity became vegetarian today, there wouldn't be any more food crisis. Thank you for listening. This has been James Ryan. My name is James Ryan, and I've been your host. Peace out. Stay tuned for a redstone computer in Minecraft and how to make one, as well as Tuneful Today, where James plays songs on AudioSurf. Wow, that sounds amazing. I bet you can't wait to see that. Heck yeah. Bye!